Hello everybody, Mr. Rasmussen here. Hopefully you're having a wonderful day. Let's start off with 8.1, the essential question. What is the importance of a polynomial's degree when adding or subtracting polynomials? I will say there is large importance on that. Let's do some vocabulary. Polynomial is a monomial or a sum of monomials. So monomial or a sum. So for instance, 7x could be a monomial. Polynomial, 7x plus 2y plus 1. That is a sum of polynomials. A binomial is a sum of two monomials. So now these are specific types of polynomials. So binomial, there's a name when it's just two monomials, like 7x plus 2. That's a binomial, 7x plus 2. Trinomial is a sum of three monomials. So a common one would be like 3x squared plus 2x plus 8. So it's just starting with squared, x, constant. A degree of a monomial is the sum of the exponents. So if it's like 7x squared x cubed, that would be a degree of 5. 7x squared x cubed would be a degree of 5. So that's just a degree of a monomial. Now the degree of a polynomial is the greatest degree of any term. So you figure out all your terms, and whichever one has the highest degree of the monomial, that is the degree of the polynomial. So you don't add up all the polynomial ones. You just say, okay, which one has the biggest degree? And we'll see examples of that. Standard form of a polynomial is written in greatest to least degree of a monomial. Greatest to least. And here are the coefficients. Our leading coefficient is the coefficient of the first term. Obviously, when it's in the first term, that means it's the one with the highest degree as well. So a 0 degree is called a constant. So it would just be like 7. A linear, so that would be, and the linear would be something like just, 3x. Let's get my pen back, not the eraser. Okay, so again, like I said on this one, a constant would just be like 7. A linear would be 7x because it has a degree of 1. There's no variable on that, so that's why it's just constant. A quadratic, we would say this would be like 7x squared. And you can have stuff like plus 3x plus 1 quadratic, or it could just be 7x squared. A cubic, you'll see like 7x cubed plus 3x squared plus x plus 5. So the highest degree is 3 of this polynomial. Quartic is for 4, quintic for 5, and 6th degree and above are just 6th degree, 7th degree, 8th degree. No special names. So there we go with the names of constant, linear, quadratic, cubic, quartic, depending on what the highest degree is. Okay. So now let's get to adding them. So adding them, you're going to add the ones that have the same degree. So for instance, I have 7y squared plus 5y squared. So that ends up being 12y squared. 2y minus 4y, so that's minus 2y. Minus 3, negative 3 plus 2 is going to be minus 1. So on this one, the highest degree is 2, and then you go to 1, and then 0. So the highest degree is 2, so that means this is quadratic. So quadratic, and there's 3 terms, so we're going to say a quadratic trinomial. Okay. Moving on to example 2. By the way, does anyone know what you call a seagull that flies over a bay? A bagel. Woo-hoo-hoo. Sorry, that's a good one. So now, again, 4x squared plus 3, no, just kidding. We have to go to minus 7x squared. So 4x, so it's going to be minus a 3x squared. Now we'll go with negative 2x plus 3x. So that's going to be plus x. And then a 7 minus 9, so it's going to be minus 2. So the highest degree is 2. So again, we have a quadratic. And then there's 3 terms, so trinomial. So yes, it's still a polynomial, but there's a specific name for 1, 2, or 3 monomials. And this one has 3, so it's a trinomial. Now we're going to move on to subtraction. Now the key thing with subtraction is please make sure like you're technically subtracting each one of these terms since it has a parentheses around it. So 6y squared, no, we have to start with the 4th degree. So 8y to the 4th minus 9y to the 4th gives you negative y to the 4th. So those are done. Then we'll go to, looks like the next highest is squared. So we got 6y squared minus 2y squared. So that will be plus 4y squared. So the y squareds are done. Negative 5y minus a negative 7y. So don't forget about minus a negative, which becomes plus. Negative 5y plus 7y becomes plus 2y. So in this one, we have a highest degree of 4, so that's going to be quartic. And then there's 3 monomials, so that's going to be quartic trinomial. Example 4. Well, the first one I have is a 3rd power, but there's nothing else to the 3rd degree, so we're just 11n cubed gets to stay by itself. Move on to, looks like the next highest is squared. 6n squared minus 5n squared. So it's going to be just plus 1n squared or plus n squared. So those are done. And you end up with 2n minus 4n. So minus 2n. Those are done. And then a minus 3. Yep, you're right, plus 3. So here we have 4 terms. So that's going to be a quartic, never mind. The highest degree is 3. So the degrees goes first. So that will end up being a cubic. And then there's 4 terms, so that's just polynomial. No special names for 4 and above for the number of terms. Polynomial is the name of the game. Okay, so let me bring the shade back up. You have the example 5. The total amount of toy sales, T, in billions of dollars, consists of 2 groups. Sales of video games, V, so this is the variable for that one. Sales of video games is V. Sales of traditional toys is R. I'm not sure where R came from. But in recent years, the sales of traditional toys and the total sales could be represented by the following equations. So again, I go back to total sales is going to equal your video games plus your traditional toys. So the total equals the videos plus the traditional. Now here's your long equations for R and T. So we need to find actually what V is, not T. So here we have writing an equation to represent the sales of video games. What were the sales of video games in 2009? So I need a V equals. So I'm going to subtract R from both sides. And I'll have V equals the T, total sales, minus the traditional, should end up being my video games. So that's how I'll write it. Here you have V equals the total sales minus the traditional. Now see the minus, so that means we have to distribute that minus to each one of those. So we have 4 different ones to go to. And then only subtract the ones with the like degree. So the degree of 3, degree of 3. degree of 2, degree of 2, degree of 1, 1, none, none. So here, these are actually each both cubic polynomials. Cubic because of degree of 3, polynomial because there's 4 different terms. When I subtract them, that's my next part of the equation. And then 2009 is what I'm looking for. Well, years since 2000, that's 9 years. So for n, I'm going to plug in 9. And then you'll see order of operations. I need to do the exponent before I do the multiplication. So 9 cubed times that. 9 squared, 81, times 0.05. So those are order of operations you need to be careful of. And there's all of our numbers. Now just add them together and you get 12.96 video games. So 12.96 video games, so about 13 video games in 2009. Well, never mind. 12.96 billions. Sorry, no, hold on. Number of years, hold on, in recent years of traditional sales. Okay, so we're looking for V, so yeah, billions of dollars. My apologies, yes, 12.96 billion in sales. I don't know why I went back to the mouse to write. 12.96 billion in sales. All right, hopefully that makes sense. Otherwise, please ask questions in class. Sayonara.